Okay, in this video I'm going to talk about the two tangents to a circle from a point, and that they are equal to each other. So basically we have a circle, we have some point, and we draw from this point like both tangents to this circle. So like something like this and like this. So there are only two tangents, and so we consider these segments from this point. So let's let this would be point P, and this the points of tangency. So denote them by T1 and T2. Okay, so and basically the theorem says that these two segments PT1 and PT2 are equal to each other. So PT1 is equal to PT2. Okay, so let's prove this. So I need to erase the fact that they're equal. We don't know that yet. Okay, so we consider the center of the circle O, and we draw these segments to the tangency point. So we know from another theorem that I proved in another video that the radius at the tangency point is perpendicular to the tangent. So we know that this is a right angle and this is a right angle. So OT1 is perpendicular to PT1 and OT2 is perpendicular to PT2. So now we see that basically we consider this triangle POT1 POT1. So it's a right triangle. Well, basically we can, so when we consider POT1 and the triangle POT2, like these are two right triangles with the same hypotenuse and equal one other side. So like there is a kind of a theorem that says that in this case the triangles are equal to each other, and then we conclude that the third side is equal. But we can like kind of prove this theorem here as a side note. So basically, like if we consider the triangle POT1, so then by the Pythagorean theorem we have that PT1 squared plus OT1 squared is equal to PO squared, right? So then, OT1, this is equal to the radius of the circle. So this is equal to R, and OT2 is also equal to R, to radius. So this would be R squared, and then so like if you write the same quality in the other triangle, like this would be the same, this would be the same, therefore this is the same, but like to write it carefully. So from this we conclude that PT1 squared is equal to PO squared minus R squared. And the same when we write the Pythagorean theorem for the triangle POT2, we get so let's erase this here. So we get pt2 squared plus ot2 squared is equal to po squared, right? So again, this is equal to r squared, and so from this we conclude that pt2 squared is equal to po squared minus r squared. So the right hand side of these equalities are the same, therefore the left hand side are the same. So from this we conclude that pt1 squared is equal to pt2 squared, and since the length of the segment is always positive, we can remove the squares. So they are equal without squares. So and this is basically what we need to prove, that these two segments are equal. So this concludes the proof.